Yeah. Yep.
Oh, it doesn't.
Yeah, you have to project.
Or if you're talking to those guys that have been sitting next to those for 20 years and they can't hear you whether you're
Oh,
talking.
my
to them.
ears.
Yeah,
scream.
you gotta yell at them.
You have to yell at me. Yeah.
Look at that.
Just like that?
Yeah.
Weird. But now great.
She just laughed at me and I was
I'm
like,
sure.
I honestly have no clue what I'm doing.
Like, oh, I didn't know what I was.
All right, as for today, we are looking into the rest, a decent amount of chapter 7. But the good news is a lot of this is the same stuff we saw before, which is factoring. And then it's basically factoring with just a little bit of canceling. In order to do this, though, this all comes back to, right, said it in the beginning, fractions are important. So this is still dealing with fractions. So we have to remember the base concept of fractions. When you multiply fractions, all right, how do you multiply? Just straight across, that's it. Now it becomes 5/12. When you divide fractions, what does that actually become?
3/2 times 9/7.
Right, so remember, leave it, change it, flip it. These are arithmetic principles. We're just gonna then apply some algebra to them. All right, so 2 base principles, all right? And we deal with the fractions first, and then we work through all the pieces of the algebra. So, all right, I have a fraction divided by a fraction. So the very first thing I'm going to do without messing with anything is I'm going to change that division to multiplication and flip the fraction. So I start with that, then I'm basically looking, that whole thing is essentially under one giant fraction now. And that's how I can view that. Once you have everything being multiplied, you can put it all under one fraction, or you can leave it separate. It's the same either way. Then it goes back to factor. Break your pieces apart until they are the smallest versions of themselves. X plus 1, can I break that down any?
No.
No, that's as small as it gets, all right? X squared minus 1 and x squared minus 2x plus 1, those I can break down. All right, so just one piece at a time. So starting with the top right piece, what do I need to do to that to break that down? Diamond. One and -2. What are the factors? Yeah, -1 and -1. Kaylin, is this a special case? Or is this the simplified diamond or the full diamond?
Oh, it's simplified.
So it's simplified, how do you know?
Here's your number in the first term.
Yeah, once again, okay? And we run across these a lot. Okay, so we get the simple diamond in a lot of cases. All right, so this becomes, the numerator is now x squared minus 1. What does that factor to?
X minus one, X plus one. Yeah.
Right, that's our difference of squares. Now I could do the diamond on that, but those are really good to be able to be, if you can recognize those. Because this guy, right, this is a difference of squares. So being able to recognize those is very, very helpful. And you can still diamond, but remember that's the funky diamond with 0 in the bottom, right? -1 in the top. Once I'm here, now what do we get to do? Cancel. All right, x plus 1 and then x plus 1. All right, and it's not cross cancel, it's just 1 in the top, 1 in the bottom. Doesn't matter which one you pick as long as it is the same. And x minus 1 and an x minus 1 and x minus 1 and x plus 1 cancel too, right? No. So that's as far as we go. So I end up with an x minus 1 divided by x plus 1. Knowing where to stop, all right, that is important as well. So something that had a bunch of pieces to start simplifies down to one simple polynomial over one simple polynomial. All right, so this is fraction times a fraction. So do I need to flip it? Need to flip it? No, because it's already being multiplied. Multiply straight across, which means, all right, again, I can write that as one giant fraction and then just start pulling pieces out. Now you can keep them separate too. That's kind of a judgment call. All right, so for the top left piece, what should I do with that one?
Pull the 7 out.
Pull the 7 out. What remains inside the parentheses? Hannah? Sorry, A minus 2, that is exactly correct. What do we do with the top right one?
This goes straight to diamond.
That's diamond. All right, for the diamond, all right. What goes in the top? 5. This is a full diamond. What goes in the bottom?
Yep, 6, yeah.
So what multiplies to 5 and sums to 6? 5 and 1. And that just becomes a plus 5, a plus 1? No, full diamond. So we have to do that all the way out. Rewrite the middle term using the factors. Remember the first term and the last term, they did not change. That was 5a squared, 5a squared and 1, right? So those did not change. You're expanding it. Once you have this written like this, now what do we do, Fred?
I don't know. I'm still catching up on your right.
Brian, what do we do? How do I factor this guy?
No.
You take the 5a squared and you add it to the other 5a squared.
5a squared doesn't add any, no common terms.
Yeah. Understand.
Get that together.
I don't have it on this one. General factoring. When we generally factor stuff, we count the number of terms. There are 4 terms here. What is our main technique? Only technique for factoring 4 terms? Grouping. Remember, when you feel lost, when you feel confused, when you're not sure what's happening, what should you do?
Start dancing.
Dance. Remember grouping. That was the grouping move, right? Every time, almost every time. Dancing always solves it.
Yes.
Factor by grouping, 2 by 2. Gonna pull out 5a, that leaves a plus 1. What do I pull out of the second 2 terms? Maddie?
For the second one,
Yes. So the first two terms, I pulled five A. All right, so when I pull five A out of five A squared, that leaves an A. Pull five A out of five A, that leaves a one. What do I pull out of the second two terms?
One.
One. All right, and it is crucially important to make sure you identify that one specifically, plus one. Remember to keep your addition in there. And then pull it all the way out. That leaves five A plus one times A plus one. And that can now go all the way up here. So again, all this is just factoring, but now we have 4 pieces to factor, right? And then 6 pieces and then 8 pieces, but it's all still just one piece at a time. I got to get through that entire factor. Then I go to the next one and the next one. All right, put it all together and then just see what you cancel. Everyone panics over these problems because they're, oh my God, someone, one step at a time, one step at a time. All right, let's look at 4 minus A squared. So for this guy, what should we do and what do we always need to do? 4 minus A squared, so I just pulled this piece. It is a difference of squares, excellent, but it's kind of,
Yeah, it is.
what's wrong with it?
It's not
It's
descending order.
Descending order. So always good to change this to descending order. And then you are absolutely correct, Anna. This is a difference of squares. But in order to kind of help me with that, I change it to descending order. Then I'm gonna pull a negative out. I pull a negative out, and then it's super easy to see the difference of squares. So I have a negative, A minus 2, A plus 2. So descending order, then I see a difference of squares, and then I can factor that. Hannah?
Isn't that a positive 4? When she did it in descending order, wouldn't it still be a positive 4?
It is. 4 minus A squared becomes negative A squared plus 4. Then I pulled the negative out. So I switched that, became positive, that flipped to negative.
Okay.
Never mind. Thank you.
Yeah, so that step process can be very, very helpful to make sure that we're organizing our terms, writing them correctly, and I'm just doing one step at a time. Now we could put that guy there. And then the last one I should be able to just do directly, 35A plus 7. What do we need to do on that bottom? Pull the 7. So pull a 7, that becomes then 5A plus 1. And then always when you did this correctly, you should see a bunch of stuff that should line up to be canceled, right? I see, let's see, 5A plus 1, 5A plus 1. A minus 2, A minus 2, and oh look, a 7 and a 7.
Okay, so those two can cancel out,
Which two?
like when you pull the greatest common factors, that's.
Oh, sure, because technically that, I wrote it there, but that 7 could come all the way to the front. Remember,
Okay.
5 times 7, 7 times 5 is the same, doesn't matter where you write it within there. There is multiplication signs in between every single piece of this. 7 times A minus 2 times 5A plus 1, right? Same thing, A plus 2 times 7 times 5, yeah.
Okay, sorry, no, that's the next piece.
We okay?
Yep.
All right, and then let's see what ends up. So we have A plus 1 all over negative A plus 2, which then I could write as negative A plus 1 all over A plus 2. And that's as simple as we can get that. Yeah, Brian.
Why would it be negative A? Why would it be negative A plus 2?
Because I had this negative here
Oh,
from the factoring. And technically, I'm writing this as negative. What is this actually? What number? -1. So some people like to write this as -1 just to keep track of it. Because yeah, right down here, this is -1 times A minus 2 times A plus 2. And so I could write that as a -1. but I just know that it's a negative. And you definitely should pay attention because watch that sign. All right, signs. All right. One of the other interesting things is whether you have 2 terms or 10 terms, you still deal with each fraction singularly. So this one will remain. I will leave it, change it, flip it on this, but this does not also flip. So this is still multiplied. This is the only one that needs to flip with its appropriate operation. Okay, so that people get that messed up, but it doesn't matter if there's 50 more following it. Only that single fraction will flip. Once you have everything lined up and being multiplied, then we can start breaking them apart. But notice only this one fraction, right? Leave it, change it, flip it with that fraction. Remember, algebra actually moves left to right. So I resolve this, then I look to the next step and see if I need to change this one. If this was divided as well, this one then would flip and change the operation. All right, and then we can pull this apart piece by piece. So let's start with this one over here, 6 and 5, and actually we just did that. Oh, no, we didn't. We did it the other way. What multiplies to 6 and sums to 5?
2 and 3.
2 and 3. All right, and this guy down here, -12 and -1.
It's -4 and 3.
-4, +3. These are my favorite because are any of these full diamonds? Nope, they are all simple diamonds, which means I can jump to the factors. That's all the work I needed to do. And I can write this whole thing out. And again, personally, I like to put this all under one giant fraction. You can keep this as 3 pieces, okay? But I like to put this under one giant fraction. It just feels easier to me. And it continually reminds me that you multiply straight across. Doesn't matter if there's 50 fractions in there or 2. And I can put the 1 there, but I just dropped it. No. All right, and then let's see what cancels. So what is something that cancels? Y squared.
That one actually should probably go there.
It doesn't have to, because
Oh, it could just be 1 + 2.
let's put the 1 there just for the minute so we can see y + 2 over 1, anything over 1. And yeah, look how nice that is, right? 6, all right, pieces reduces down to almost. And that's what we're trying to identify, right? Notice the instructions. Simplify, simplify, simplify. All right, look, simplify. All these instructions say the same thing, okay? We are trying to get this into the simplest form possible. To that end, continuing with our fractions. So, all right, when you have a common denominator, all right, you simply add the numerators. So this becomes 4 + 1 becomes 5, denominator becomes 6, 3. Do not change the denominator. Again, I know the temptation is when we start putting variables in there, everyone forgets their arithmetic. This is just arithmetic. So remember those rules and every time write it down. I was like, make up 2 numbers and add them together and verify with your calculator when you actually have values, all right, to make sure your logic is consistent when you change it to algebra. And same thing, if it was subtraction, I would subtract this. So when you have a common denominator, all I have to do is that's still all over x, and then I just have 3 plus x plus 4, and I could simplify that down. And then I can cancel those x's?
No.
No, cannot cancel across addition, which means that's it. We talked about KISS, right? Keep it simple.
Stupid.
People get offended when I add the second S. It was actually taught so to me as keep it simple sailor,
Oh.
because my instructor went to West Point. And so he was like hardcore. And he was always like, keep it simple, sailor. And when he get pissed at us, then he'd call us stupid.
Nice. Sounds good.
All right, same thing. X minus 4. All right, now I'm gonna write this out because x squared, that negative, remember, comes into the entire numerator of that second term. So it actually looks like this. The temptation is people forget to do what part of the dance with that negative? Rainbow. So this becomes x squared minus x minus 12 all over x minus 4. The important part, remember this says simplify. We need to get this as simple as possible. So every time you do a step, then look, can I do anything else? Can I do something with this numerator here? Specifically what?
You can diamond it.
Diamond. I can diamond that. Right? When you feel lost, confused, scared, diamond, dance. And that's exactly the same diamond we had above, -4 and 3. That is also a simplified diamond, which means I can jump to the factors. And oh, look.
Wait. Yeah, okay, you can cancel it now because it's not subtraction or addition, right?
Excellent. Thank you for bringing that up. Once again, at this stage, I know I have an X right here. I know I have an X right here. I cannot cancel those because that is a cross addition. All right, subtraction is just addition with negatives. All right, but now, all right, I have, all right, things being multiplied, that times that, and technically x minus 4 times 1, right? There's always a 1 everywhere, okay? So that means I multiplied in the numerator, I multiplied in the denominator. I can definitely now cancel. And that just leaves x plus 3, or x plus 3 over 1. And that's always what we are going to try and identify. All right, to that end. So the denominator doesn't move. Nothing changes in the denominator. And then I have 3 plus 7 and -2x plus -3. So let's add those, and then always helpful to write in descending order. And then notice these are exactly what we were starting with, all right? In the very beginning of chapter 7 last time, because now I just have one big fraction over one big fraction. I want to see if I can break those down and see if anything cancels. So in the numerator, what should I do? -5, right? Whenever possible, that sign is a big deal. See if you can pull that sign all the way out, which is also, it is also much easier to identify if you always write things in descending order. All right, so that's always one of the biggest keys to help identify what you need to pull out. And then down here, I have a nice easy diamond. What multiplies to 8 and sums to -6?
-4, -2.
And oh, look, once again, right? Now, is it possible that you factor the numerator, you factor the denominator and stuff won't cancel? Of course, all right? Most of the time, we're like, the problems in the home fund, the problems in the activities, trying to pick problems where stuff does cancel. If you get down and nothing canceled, double check everything. It's possible, yes. It's likely, no. X minus 2's.
Oh, so
-5/x means 4.
And that's exactly how I would leave it. You can write that as -5/x minus 4. All right, you could also bring the negative in to mess up the descending order down there, but that's the most appropriate way probably to write this one. Just like we had before, 5 terms, 2 terms, 20 terms, all right? Process still remains the same. All right, adding fractions still follows the same concept. Add all the numerators, all right, keep the denominator the same. But actually, we should do one more step here, 6. Okay, I can do that, 6x minus 1. Just as a note, that middle term is the only one that's kind of annoying, all right? Because, all right, we have that negative out front and a 3, so it's easier, pull that negative with the 3, and then just rainbow that guy. Okay, so that goes away and actually, oh, yeah, negative 15.
Yeah, you can, okay.
I was just writing it out so we could keep track of everything, but yeah. I was like, not much to do there. The big part about this one is, once again, that negative, all right, has to be rainbowed through, all right, the entire numerator piece of the fraction that is associated with. Way too often, just people forget that negative, they only bring it in a half, but it's still just rainbow. All right. Yes, Brad.
So did you just rainbow that just to make that 2x plus 5 just more similar?
Yes, I mean, rainbow it, I had to rainbow that to make terms that I could see if I could combine. Because I can't tell -3 times 2x plus 5, I can't tell what that is. And if that'll, how that adds to other common terms. All right, so when things have a common denominator, that's the simple version. When they do not, we have to create the least common denominator. When we create the least common denominator, we have to really look at the fractions. So let's start with a simple case, back to our arithmetic. 1/2 plus 1/3, what do we do conceptually?
2, 3, and then plus 2/3.
You identify the common denominator, identify what's missing in one, what exists in the other, and multiply it, remember, by 1. 3/3, 2/2. We're not changing anything because I'm multiplying this by 1. I'm multiplying this by 1. Ones are everywhere. It does not change anything in this equation to do that. Then I end up with 3/6 plus 2/6. And then we're back to our, now we have a common denominator. Add the numerators directly across. Do not change the denominator. Now I know, all right, everyone should know how to do this. And when we have arithmetic, it seems very clear. When we start getting algebra in there, everyone gets messed up. So we follow the same principles though. What is the common denominator between 36x squared and 24x? Definitely not 12.
No, it's not.
If you're having a hard time, which, it was like, if anyone got it, you're just really fast at math, that's great. I was like, but if you're having a hard time, break it down using prime factorization. So let's break this one down and let's break this one down. 36 and x squared. All right, so what are two numbers that multiply to 6? 36. I think I hit on one of them. 6 and 6. And then I could break those down, 2 and 3, 2 and 3. And this guy breaks down to x and x. Okay, so that's the prime factorization of that one. For 24x, down to 24 and x, what are two numbers that multiply to 24? 2 and 12.
6 and 2.
And then 2 and 6, and then 2 and 3. When you have huge numbers, this is always the best approach. Now, let's write this out again. Hold on, I need some extra space. Okay, so this is 2 times 2 times 3 times 3 times x plus 7 all over 2 times 2 times 2 times 3 times x. When you write everything in its prime factorization, so all I was doing was grabbing the primes here. All right, the bottom numbers here, and then 2, 2, 2, 3, and an x. Right? 2 times 2 times 2 times 3 times x makes 24x. 2 times 2 times 3 times 3 times x makes 36x squared. So I'm writing those same numbers again. Then I just look much more simply. What is in this one that's missing in that one, and vice versa?
Another X.
Okay, so I need another x in this one. Anything else? And then, hold on, which one are we doing? We're doing this one. Definitely need an x over an x. What else do I need over here? A 3, right? There are 2 2s. Okay, there's already 2 2s. All right, there are 2 3s. Oh, there's only 1 3, so I need a 3 over here. What about this guy? What's missing there?
A 2. 2.
A 2, that's it. There are 3 2s over here. There are only 2 2s over here. Everything else, oh, I got 2 3s, there's 1 3, got 2 x's. So the only thing I need in the other one is a 2. And so big numbers that looked complicated, when you break them down to their prime factorizations, you literally just identify, it's always going to be a small number that's usually missing. This is how you can do all common denominators, right? And we went through this when we way back in chapter 2. So, all right, 5 times 2. All over 7 times 3x. And now the denominators are the same. 2 times 2 times 2 times 2 times 2 times 3 times 3 times x times x. So actually, in order to check the math, what's 36 times 2? 72.
Right.
Yeah. That's what that actually becomes. 2 times 2 times 2 times 3 times 3 times x times x. 72x squared. Can I combine the numerators anymore? No, I could write it in descending order, but it's fine.
But it's.
We can't simplify anything else. I was like, there's nothing else to be done here. The idea here is to create the common denominator. All right, for this guy, same concept. When your fractions, they're all mixed together and messed up. You need to break it down to their simplest terms to identify what is in this one that's missing in this one, what is in this one that's missing in this one, and vice versa. All right, so that's what we need to try and figure out. The only way to do that is I need to factor the denominators. Good news, this guy should be pretty easy. -6 and 5.
6 times -1.
And then this guy, let's write out the diamond just for practice. -1 goes here. What goes in the bottom again? 0, right? This is that tricky diamond, which also you could identify if you just say, oh, that's a difference of squares. Okay, so this actually becomes x plus 3 all over
8x.
So same thing, I just have it now factored. I can't combine these yet because these are not common denominators yet, right? So you can't just add these straight across or anything, all right? Now we have to create the common denominator, but we do the same principle we just did above. What is in this one that's missing in this one? What is in this one that's missing in this one? So let's start with the first one since it's right here. We are missing an x plus 1, right? There's an x plus 1 over here. There is not one over here, which means I need to multiply it by x plus 1 over x plus 1 because I'm multiplying by 1. And for the second one, x plus 6 over x plus 6.
That's when we get the really questions. Okay.
So, all right, just writing it out. All right, I didn't do any simplification yet. All right, x plus 3 times x plus 1 plus x plus 7 times x plus 6, all over the same denominator. That is what we just accomplished. However, we need to continue to simplify this. Sometimes it's got to get worse before it gets better. What can I do? And be aware, I cannot cancel anything. Why? Still a big addition between that whole thing and this whole thing. So what do I need to do? Yeah.
Or multiply.
Box. Yes, oil is correct though. All right, but yes, all right, I have 2 boxes to be done right here. I will convert you before the end of the class.
I'm using it on all my homework. It's so much better than oil.
In order to see if we need to combine basically 2 quadratics, combine them, see if they factor again to then cancel. Now, they may or they may not, I don't know. But we definitely need to box them together to at least simplify a little bit. So x plus 3, x plus 1, so I'm doing the left one on the left, the right one. All right, now be aware, I could have literally combined all those in one step here, but I just wanted to keep showing, all right? This is still the same one that was there, all right? This is the same one that was up there. And then now I can finally add all these pieces together and see if we can add them together and then they break down again. All right, so x squared plus x squared. 2x squared. Two x squared plus 17x plus 45. And then what should we do? Deep breath. Diamond. We actually get to see if we can diamond this again.
Put it together. Take it apart.
We put it together, put two individual quadratics together to see if they can separate individually, right? We already simplified. We turned 6 terms into 3 terms, so that's already a win. All right, what goes in the top of the diamond here? That's 17. And already I know this is pretty bad news because 17 is prime, which means the only options I really have are 10 and 7. Does that make 90? No. 1 and 17 makes 17. So that means this does not, I know we're really broken up, that it does not factor, which means that is as far as we can go. But how satisfied would it have been if we could break that apart? It's like, so doesn't always work, but it is just as important to know when you have to stop. Okay, you should check it, but oh, I can't do anything, so I stop right here. All right, knowing when to keep going, knowing when to continue. Go ahead, Brian.
I was like, I'm honestly glad we stopped when we did, because I was trying to get a space.
You're missing your part.
Not.
All right, again, can I just add x and -2? Because they're unlike denominators, right? They're not common denominators yet. Which means I have a couple of easy diamonds to do. 6 and 5. 2 and 3. 2 and 3. Other one. 1 and 2. So I have those completely factored.
First one, right.
And excellent, yes, getting very good. Okay, someone besides Anna. Brian, what do I multiply the first one by?
1.
Not just 1. What is in denominators? What is in the denominator of this one that's missing in this one?
1. No.
Not just a 1. X plus 1. So I need to multiply the first one by x plus 1 over x plus 1. Fred, what do I need to multiply the second one by?
X plus 3.
X plus 3, well done. X plus over x plus 3, important part there. All right, x plus 3 over x plus 3 again. All you do is look in the denominators. Ignore anything that's happening in the numerator because we're trying to make a common denominator. Once I have a common denominator, and then the important part, remember that negative. This is why I like to write this next step. So I have x times x plus 1 minus 2 times x plus 3. Because that negative goes with the entire piece of this numerator. Now it's just a little bit easier and clearer for me to know, oh, I need to rainbow that whole -2 in. And I'm gonna rainbow the x in as well. And then at every step, what do we always need to do, Maddie?
Check it. What do you mean? Simplify?
Simplify, all right? Combine like terms, simplify wherever we can. Then Hannah, what do you see? What do you see here? Does anything jump out at you? Ah, I see a diamond in the numerator. This is where we were last time, but we couldn't do anything, so let's see if we have any luck this time. -6, -1. What multiplies to -6 and sums to -1, Kaylin?
So 6 and no. Is it a 6 and 1? But I don't know if it's negative or positive.
I don't think it's 6 and 1.
Oh, 3 and -3 and 2.
Be aware, and Anya, you found this out. 6 actually is the most complicated one. Even though there's literally only 1 and 6 and 2 and 3, that's the one I see people mess up the most because you're like I've seen people literally fill in 6 and 1 there without actually checking the diamond part because they're like, oh, I totally know what multiplies to 6. Okay, so just be aware. I was like, always make sure you really okay, that multiplies -3 times +2 makes -6, -3 plus +2 makes -1. Make sure your diamond actually fills in appropriately there because I see people mess that one up because they're like, oh, I know what multiplies to 6, of course. All right, so then that breaks down. So we end up with x minus 3, x plus 2, all over x plus 1, x plus 2, x plus 3. And then one last step, all that work to do what, Anna? Cancel those x plus 2s. That is then as far as we can go. So much work for one little cancellation, right? But very rewarding, right? I think that you're using the wrong R word. Rewarding, I think, is the one you were looking for.
Is that what it is?
Yeah.
Oh.
All right, one more. All right. We already encountered this actually like twice today, but it is crucially important to keep doing it. What's the big problem with this? Descending order. Okay, every time. That clears things up so much, mostly because I see people and they're like, oh, I need to create the common denominator here. But if you put this in descending order, you might see something a little bit clearer.
Okay, so if we pull the negative, would it be X minus 7?
Yes, so then I see, once I put this in descending order, I see, oh, well, let's just pull a negative out of that second fraction. So then that becomes this. Now these are almost the same. Remember that negative, all right? So I have a negative in that denominator there, but what can I do with negatives and fractions?
By negative one.
I mean, I can, but I can also,
I'll move it to the numerator.
Yeah, you can put it in.
I can move it in the numerator, or I can just pull it all the way out of the fraction. So I can pull it all the way to the front, and oh, look, negative, what's negative, negative? Plus. Which means I end up with 5 x minus 7 plus 3x x minus 7. So I actually had a common denominator all along.
Just be 8x over X.
Yeah, what, and this, now, this is a nothing problem. Yeah, 8x all over x minus 7.
Okay, that was nice after the other one.
After the other one, that was a solid, like, problem to follow up with.
Thanks.
The big thing about this, okay, is that when you first look at this, it's like, oh, and you're just very used to doing, try and create common denominators. So you start creating common denominators and your problem gets 10 times worse. Okay? Don't make it hard on yourself. Descending order and that negative, watch for that negative, Brian. Okay? That negative is the easiest thing to pull out, and then the whole problem simplifies very, very quickly. All right, okay, we will cut it right there. Deep breath.
It's a lot.
Yeah, that's fine.
That's.
Yeah.
Very much.